Hey, hello and welcome to today's GFG problem. Today, hope you're doing well. So let's say today's problem, alien dictionary. So it's a hard category problem. Okay, so let's see what the problem is trying to tell us. The problem is saying is we'll be given a new alien language, okay, which uses the English alphabets, okay, but the order of the letters is unknown. Okay, the order of the letters can be anything. For example, right? In our case, if there are English alphabets, then what is the order of letters? A, B, C, D, E, F, right? Like and so on, like this. But here in the aliens language the order is different and it is unknown. Okay, so what the problem is saying is we'll be given the words of the aliens. Okay, we'll be give the words, and the words are claimed to be sorted lexicographically. Okay, sorted lexicographically. So we'll see what does this mean. Okay, so what we want to do is we want to determine the correct order of letters. Okay, or the correct order of letters. So what is the correct order? So for example, in our case, right, in English case, right, it is A, B, C, D, E, F, right? So from these words, right, from these words we want to determine the correct order. Okay, the correct order of of the of the words. Okay, the correct order of the letters basically. Okay, so here for example, so when they say there it is lexicographical, let's see with the example CB, CBA. So let me ignore the double quotes. Okay, and BC, right? So here, so what does this mean? What we will do is we will compare. So since the words are lexicographically sorted, so we'll compare the word with the next word, right? So here, if you see C and C, both are same, right? C and C both are same. B and B both are same, right? And then there's no letter after this B, okay, but there's letter after A. So here we are going to ignore. Okay, the order is correct because the characters are matching, but even though the length is not matching, right? The previous word, the length is not matching, we'll stop here. Okay. Now what we'll do, we'll go to the next word and we'll compare it with this word, C, B, A, and C. So here if you see the first character C and A, they are not matching. They are not matching. That means, what does this indicate? That means in aliens terms or in aliens language, C appears before A. C appears before A. Okay, so we'll break here. So wherever the characters mismatch, that's it. You need to, like, you can break from there. No need to check for the remaining characters, because we have found that there's a mismatch and the character in the previous word, right, appears before the character in the next word. Okay, so this is what lexicographically sorted means. Okay, now what we'll do, we'll compare, we'll go to the we'll compare this A word with this next word BC. Okay, now again, if you compare the first letters, right, they're different. That means A appears before B in aliens language. In aliens language. Okay, so now if you see, so we have these two, we can say edges, and what will be the final? What will be the final? So for example, so before B, A appears, and before A, C appears. So this is the order of the letters in aliens language for these set of words. For these set of words. So CAB. So I hope you've got the problem. Okay. Okay. Now how can you solve this problem? So what we are going to do, we are going to use the concept of topological sort. Okay, so we'll see how you'll understand when we code. Okay, so what we are going to do here is we are going to take two uh, two maps. Okay, one will be in degree. So let's see key value. So this will be one map, and second will be key value again. Okay, now this will be the graph. This will be the graph map. Okay, wherein the key will be the character and V will be set of characters. Okay, set of characters. We'll see, you'll understand. And this will be in degree map. Okay, so this will be this the key will be character and the value will be integer. Okay, so let's see. We'll go through each words and uh, we'll fill up these maps. Okay, so here, what we're going to do first, we'll take CB and CBA. Now we will iterate whatever is the minimum length among the two words. Okay, we are going to iterate. We are going to iterate. Uh, yeah. So we are going to iterate through the minimum length till the minimum length of among the two words. Okay. And before this, we are also going to initialize these maps. Okay, initialize these maps. So what it is, how it is going to look like? So A 0, B 0, and C 0. Okay. So what does this mean? We are going to iterate through all the words. Okay, all the characters from all the words, and we are going to initialize. We are going to add those characters right in this in degree map, and we are going to initialize them with 0. Similarly, here A, B, C. So this graph is what? It is character and set of character. Okay, set of character. Okay, so what does this mean? Character and set of character means, so the key is the character, the value would be set of character. So here just we'll say like this, just initialize like this. Okay, just initialize like this. Okay, once the initialization is done, we're going to take the two words. Okay, and we are going to iterate till the minimum. We're going to iterate till the minimum. Uh, uh, yeah, till the minimum minimum length. Okay, so here in this example, as I said, right, CB, both are matching. And then the length exhaust, right, for this particular word. So we're going to stop here and we're going to move to the next word. So we are going to take CBA and A, right? Now we're going to compare this and this. We're going to compare this and this. Okay. Now since the character mismatch, okay. So whatever the character in the first, the mismatch character in the first word will come before the character in the second word. Okay. So what we're going to do, so whatever the mismatch character in the second word, right? So we in the in degree, we are going to say A comma 1. Because see, there is an in degree to A, right? What it means is there's an edge from C to A. When we say edge from C to A means that C is appearing before A, right? C is appearing before A. Why? Because see, these words are lexicographically sorted. Okay, so whatever is the mismatch character in the first word will appear before the mismatch character in the second word. Okay, so here, so that means we can say there's an edge from C to A. Okay, there's an edge from C to A, and the in degree of A is 1. Why it is in degree of A is 1? Because there is a incoming arrow or incoming arrow coming towards A, which is 1. Okay, there's only one arrow coming towards A right now. Okay, so that is why we added 1 to the A, right? So we added value is 1 against A. And similarly, what we're going to do is we'll add an edge C to A. So in the graph map, we're going to add an edge C to A. So what we're going to do here, we're going to add A here. Okay. Against C, we have added A. Okay. And we'll break from here because only once the characters mismatch, any characters mismatch, we want to stop there itself. Okay. Now we'll go to the next set of words, A and BC. Okay, A and BC. Okay. Now we have found the mismatch, right? We have found the mismatch in the first characters. That means what we can say, A appears before B, right? A appears before B. As I said, again, telling that the words are lexicographically sorted. So whatever is a mismatch character in the first word will appear before the mismatch character in the second word. Okay. So that means there's an in degree towards B, in degree of 1 towards B. So we are going to add a 1 here, right? And we need to add an edge from A to B. Add an edge from A to B. So we are going to add B here. Okay. And then we are done here. We are done with all the words. Now what we're going to do here is, so let me write the in degree here, key and value. Okay. And what is the state? A is 1, B is 1, and C is 0. Okay. So now what we're going to need is, we're going to need in degree only, in degree array. Okay. So we needed graph. We needed graph earlier to fill this in degree map. Okay. So now we have got this in degree wherein we are saying A and B both have incoming edges. Okay. One number of incoming edges. One edges each. Okay. Now what we're going to do? We're going to iterate through this in degree map, and whosever character has 0 in degree, we are going to add in the queue. Okay, so here is a queue. Okay, so here is a queue. So we are going to add C here in the queue. So why we are adding C in the queue? Why we are adding characters which have in degree as 0? That means these characters are appearing first. Okay, these characters are appearing first. That is, there are no characters appearing before them. No characters appearing before them. Okay, so we have added in the queue. Okay, now what are we going to do? We are going to iterate through this queue. We are going to have a while loop until queue is not empty. So we'll also have a string order. Okay, let's write it here. String order which is empty right now. So we are going to pop the whatever is the first character in the queue. Okay, and we are going to add in the final order, C. Okay. Now once the popped up element, right? Once the popped up element, what we are going to do here is what we are going to do here is whatever is a popped up element, right? So we are going to now iterate through the children or through the neighboring nodes. So how we are going to determine that? See here through the graph. Now what is a graph here? Let's see. So now the popped up element is C. Okay, and what does a graph look like? Let me write here. The graph was here. The graph was here. Let me rewrite here. A, we have B, right? Then B, we have nothing, and C, we have A. So in simple terms, if I want to represent this graph, right? How are we going to represent? How I'm going to represent A, B, right? And then C, A, right? C and A. So this is our graph. This is our graph. Now what we're going to do, whatever is a popped character from this Q, right? C, we are going to now iterate through the neighbors of C or the children of C. Neighbors of C or the children of C. Okay. So here, what is the neighbor of C or the children of C? There's an edge from C to A. Okay, there's an edge from C to A. So here, so this is the neighbor A. This is the neighbor A. So now what we're going to do is one by one, we'll take this character A now. Okay, and we'll go to the in degree map, and we are going to reduce the in degree. We are going to reduce the in degree of A. So here it was 1. We are going to reduce by 1, which will be 0. So now what we are doing here is, for example, this is a map, right? CA and then AB. This is a map, right? This is a graph basically. So what we did was we had removed C and we have inserted in the order, right? We've inserted in the order. Now there is now since we have removed C, so we want to reduce the in degree from C, right? We want to reduce the in degree from C because we have removed C from the queue, right? Okay. Now, since we have removed C, we want to reduce the in degree towards A, right? And the in degree towards A was only 1. Only 1. So we have reduced the in degree of A now, which is 0. Right? For example, if there was one more, right? There was one more edge from D to A. So the in degree of A would have been 2, right? So in this case, we would have, when we removed C, right, we would have reduced the in degree from 2 to 1 in this case because there's still an edge. Okay, but that is not the case. So now the in degree of A is 0. In degree of A is 0. So whenever the characters in degree of A is 0, okay, whenever the characters in degree is 0, that means there's no character before that character now. Okay, there's no character before this character, right? So we're going to add in the queue. Okay, we are going to add in the queue. Okay, so now we'll again iterate through the queue. Now the queue is still not empty. We're going to pop up A now. Okay, we're going to pop up what is the first character. So this is a pop-up character. We're going to add in the order A, right? We are going to append in the order string. We're going to append in the order string. And what we're going to do, we are going to iterate through the neighbor or child of A. Neighbor or child of A. So what is the neighbor or child of A? It is B, right? Here is B. Here is B. Okay. So now since we have removed A, right, from the queue. Removed A from the queue. So we will reduce the in degree of B. We will reduce the in degree of B. So B's in degree is 1. So we're going to reduce to 0. 1 from 1 to 0. Right? Now since it is 0, the in degree is 0, we are going to add in the queue. Okay, we are done here. Now we're going to check whether queue is empty. No, it is not empty. So we're going to pop this element out. B. We are going to add this B into A. And then there's no neighbor. There's no neighbor of B now. We're done processing, right? And this will be our final order. This will be a final order. Okay. So I hope you've got the intuition. Now let's go and code. I think you'll understand better. Okay. So let's go and code. So first I'll show the Java code followed by C++. Okay. So what we're going to do here is So let's code. Okay. So first of all, what are we going to do? For we'll have two maps, map of character, comma integer, which will be in degree. Okay. New hash map we'll have, and then we'll have map of character, comma set of character. This is a graph equal to new hash map. Okay. Now what we're going to do here is we're going to iterate to the words, word, words, and then what we're going to do? We're going to iterate through all the characters, char c, word dot to char array, and then we are going to initialize our integrand graph maps. Okay, put if absent we are going to use. What does this mean? What does it mean is if the character is missing, then add the character and the value is 0. We are initializing the maps. Similarly for graph, put if absent, c comma, we want to initialize, right? As said. We're done initializing the in degree and graph maps. Now what we're going to do is we are going to have n equal to words dot length, right? Words dot length. Now we're going to iterate and compare the two words, right? The words now. Okay. So in I equal to 0, I is less than n minus 1 plus I. Why n minus 1? Because we want to compare the correct word and the next word. Okay, so we'll take string word. Let's call it W1 for simplicity. Words of I. String W2. Words of I plus 1. Okay. Now what are we going to do? Int len equal to mat dot min w1 dot length w2 dot length. Okay. So whatever is the minimum length, we are going to consider that. That's what we are saying. We are going to consider that minimum length. Okay. Now what we are going to do? Int j equal to 0, j less than n length plus j. Okay. And now what we are going to do? Character char c1 equal to char c1 equal to w1 dot char add j. W2 char c2. Okay. Now if C1 is not equal to C2, that means there's a character mismatch. There's a character mismatch. So we'll say C1 is appearing before C2. Since the words are lexicographically sorted, that's what the mismatch character in the first word will come before the mismatch character in the second word. Okay. So what we're going to do here, if we're going to check here, if graph dot get C1 contains. If it does not contain, then only add. If it does not contain, I mean, we have not added this combination C1, C2, then only add in the graph and in degree. So what are we going to do? In degree dot put, right? What are we going to do? C2. Since C1 is appearing before C2, that means there is an edge from C1 to C2, and hence C2 has an in degree. In degree. C2 has an in degree. Okay. So in degree dot get C2 plus 1. Whatever in degree was there, we just want to add one more. Okay. And graph dot get C1 add C2. Okay. We are adding the edge now from. Okay. And then what are we going to do? We are simply going to break. We are simply going to break from here. We are simply going to break from here. Okay. Now, is anything else remaining? Okay. So thus we need to consider one invalid case. Okay. So for example, if W1 dot length, if it is greater than W2 dot length, okay, and 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 W1 dot starts with. I'll explain this what we're doing here. Starts with W2, then return. This is an invalid. Return empty string. That means it's an invalid combination. It's an invalid order. Okay. So what it is, for example, what is this case? Let me explain this. For example, if this is a case, if there's a word ABC and then there comes a word AB. Okay. So it is what the problem is saying is the words will be lexicographically sorted. Okay. But here since this first word has greater number of characters than the second word, right? Okay. That is one thing. And the first two characters, right? The like this complete um word is part of is it starts with right in this is part of the first few characters, right? First few characters of the previous word. That means it's an invalid combination because we can say that this is not a lexicographically sorted. Okay, this is not a lexicographically sorted words. Okay, and hence it's an invalid combination. Okay, so what we're going to do, we are going to return from here. Okay, now we are done here. Okay, we have added yeah. So what we're going to do, so post this, right? Post this, we are going to now have a queue of what? Character queue equal to new linked list, right? New linked list. And we'll also have string builder as an order, final order, new string builder. We're going to say, okay. Then what we're going to do, we are going to iterate through the in degree. Okay, iterate through the in degree, map.entry, character, comma, integer, okay, entry, then in degree dot entry set. We will say. Now, whichever characters in degree 0, we are going to add in the queue. That means no other characters appear before these characters. Okay. For example, now what are you going to check here? If entry dot get value, if it is 0, that means there's no in degree for that particular character. If it is 0, then add queue dot add entry dot get key. Add that particular character in the queue. Okay, in the queue. Okay, while queue is not empty, is empty. Okay, let's bring that order here. Okay, so let's poll character current equal to q dot poll. Remove that whatever was the first character and append to the order. Okay, append to the order. That means this is the order basically. So current, there's no other character coming before current, so add current here. Okay, then what we're going to do? Let's iterate through the neighbors. Okay, set of character NBR neighbor of graph dot get current. What is the current character? Iterate through the neighbors. Iterate through the neighbors. Okay. Now, since we have removed current, right? The current character, we want to reduce the in degree of all the neighbors because the in degree will be reduced because we have removed the current. Okay, the edge from the current. We are removing the edge from the current. Okay. So in degree dot put NBR in degree dot get NBR -1. Okay. And if in degree dot get NBR, if it is 0, then add in the queue. Q dot add NBR. Okay, Q dot add NBR. Okay. So here Okay, Q dot add in B R. So here we are done. Okay, here we are done. Only one thing remaining is, for example, let's see one more invalid case. If order dot length is not equal to in degree dot what do we say, size, right? In degree dot size, then that means there's a cycle. So we are going to return empty string. That means it's not a valid combination. For example, how it would be? For example, if the in degree was like this, for example, let's say the graph was like this: A to B, B to C, and C to A. So such was our graph. So if we see what will be the in degree, what will be the degree of all these characters? See, if it is A, B, and C, right? If it is A, B, and C, so A has an degree of 1. B has an degree of 1 because A is coming towards B. And C also has an degree of 1. Okay. Okay. C also has an degree of 1. Okay. So that means we can say there's a cycle. There's a cycle, right? So that is why it's an invalid combination, because no other characters appearing before any other character, right? All the characters are connected. All the characters are connected. Okay. And there's no in degree of any character which has zero value. There's no in degree which has zero value. Okay. And that is why here in this case, order is going to be empty, and Q will also be empty here. Q will be empty because what we are doing is whichever character has zero in degree, then only we are adding the Q. That means for the invalid case, with the cycle, this won't go, this won't be executed, right? Okay. And order will be 0. Hence, order will be 0. Order size will be 0. In degree size will be 3, definitely, right? In degree size will be 3 because here is our, irrespective of whatever it is, right? In degree size will always be greater than 0. Okay. And hence, this is a cycle. Okay. And finally, what we're going to do, we're going to return order dot toString. That's it. I hope you've got the solution. It's a hard category, but I've tried to explain it in a very simple way. So what is the error here? Okay. What is not length? What do we say? Okay. Let's submit this. I hope this should run. Okay, the test keys are being passed. Okay, thanks for watching. Please don't forget to subscribe to the channel, like the video. I've tried to make it very easy for you. Let's quickly see the C++ code. I'll also attach a code in the comment section, in the description section. Okay, so here we have in degree and graph. Okay, and then for example, we are initializing here. If the character is not there, then add 0 to C. And if that particular character is not there in the graph, then add the set. Initialize it with a set as a value. Okay, then we are returning to the words. Okay, we are taking two words. Here is an invalid case. As I've already explained, ABC, comma AB. Okay, if the first word's length is greater and the word 1 starts completely with word 2, then we have to return it's an invalid case. Okay, prefix rule is violated. Now we are taking the minimum length out of the two words, and then we are iterating through that length. We are taking the character. Okay, and wherever there's mismatch, we're going to check if it is not added in the graph, add in the graph, add in the in degree, increase the in degree of C2, and then just break. Just break. Only first difference matters, right? Only first difference matters. Once it is done here, we are taking the Q. We are iterating to the in degree map. Whichever character is in degree 0, we are adding the Q. That means no other characters appearing before those characters. Okay. Then what we are doing here is we are iterating through the Q, right? We are removing the whatever was the first character. We are pushing the result, a resultant string, and then we are iterating to the neighbors. We are reducing the in degree because we have removed the current, right? Okay, so we are reducing the in degree of that neighbor. And if that in degree if the neighbor's in degree is 0, then we are adding the Q. Okay, and finally, we are returning result. Here is our invalid case, which is a cycle. For example, the graph contains cycle, then we have to return invalid. Okay, check for cycle. Okay, thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.